Welcome to this unit on evaluation methods for machine learning models. To evaluate a machine learning model, we need to use metrics and techniques which can help develop it and deploy it. So in that, there are various ways in which we can evaluate. We'll be discussing on overview of evaluation metrics. Some of the core metrics in RStudio will be discussed, and the advanced metrics and visualization will be summarized. What are evaluation metrics and why are they needed for machine learning models? Evaluation metrics use various matrices and techniques. But what are they? They are quantitative measures used to assess the performance of a machine learning model. They provide insight into how well a model is performing against any specific criteria. So generally for this purpose, data splitting is employed, and data can be split into training sets and testing sets. It can be in the ratio of 80 to 20 or 60 to 40. It can also employ cross-validation methods and comparing model performance against a baseline, all the while considering metrics like accuracy, precision, recall, and F1 score. Model evaluation helps determine how well a machine learning model performs and generalize to unseen data, ensuring its reliability and effectiveness in real-world scenarios. In data science, especially in biology, why are evaluation metrics important? They are crucial in data science as well as in bioinformatics as they guide decision-making and improvements in models. They help in identifying the strengths and weaknesses, facilitating better accuracy of prediction and efficiency. Classification metrics can classify multi-class classification, which extend the evaluation to models predicting multiple classes. Here also we could use accuracy, but some of the differences are that here you may use macro averaging, micro averaging, and confusion matrices, providing detailed insight into the model performance across all the classes. Let's see what accuracy means and how it can be used for evaluation in a general basis. Accuracy refers to the measure of correctly predicted instances in a data set. It is calculated as true positives and sum of true positives and true negatives divided by the total instances, indicating overall performance. Accuracy commonly used in classification problems. However, it can be misleading in imbalanced data sets where the data set in all the classes are not the same, not equally distributed, and where the majority class is heavily influencing the results. Precision is also a measure having the ability to avoid false positives. It measures the ratio of true positives results to the total predictive positives. It is calculated as true positives divided by sum of true positive plus false positives. Hence, it reflects the relevance of positive predictions. Importance in imbalanced datasets. Precision becomes very crucial in scenarios with class imbalance, as discussed just now, emphasizing the quality of positive predictions and minimizing false positives, which is vital in fields like medical diagnosis. There is another way of measuring, that is F1 score, and it balances the precision and recall. The F1 score is also crucial as it effectively balances the trade-off between the precision and recall, providing a single metric that captures both false positives and false negatives. When do we use F1 score? F1 score is particularly beneficial in situations with imbalanced class distribution, ensuring that both the positive and negative classes are accurately represented in model evaluations. Final measure that we are going to discuss are the rock and the area under the rock. As we see, area under the receiver operating characteristic curve and receiver operating characteristic curve are useful for evaluating binary classification models. The rock curves illustrate the performance of a classification model by plotting the true positive rates against the false positive rates. This provides an insight into the model's sensitivity and specificity across thresholds. How do we interpret the area under the rock value? The area under the rock value quantifies the overall ability of the model to discriminate between classes with values closer to 1, indicating perfectly matched, whereas values around 2.5 suggesting no classification ability. These are some of the measurement predictors to evaluate a typical machine learning model. Thank you.